All right, page 160. I think because we went over, 161. You've seen all the right answers to 160, yeah? All right, so just mark your own. Oops. Rudder. Brother. 6x cubed y minus 4x minus 3. All right, I changed to black ink where things got a little funky. Everything in red you should have been able to get no problem. The stuff in black required you to do quite a bit of thinking. But I will give you a fancy schmancy little move that will help you with 8, 9, and 10 and questions like it, if you need it. Anybody got any questions about anything up to the black ink? Shouldn't be any questions up to the black ink, but of course if there are, I will entertain them. How will I entertain them? Well, I'll tell them a few jokes, maybe a little tap dance. No, I can't tap dance. Of course, the entertain I mean is I will answer them. Any questions up to the black ink? Any questions on anything for the black ink now?
Yes. Could you go through number 8?
I will indeed go through number 8. This is the handy-dandy trick. Well, actually, before I show the trick, I'm going to show you why the trick works. What math is happening right there? Multiply. So that x is a factor, isn't it? And that x minus 2 is a factor, isn't it? So if those are both factors, that must mean that I could divide by the greatest common factor, couldn't I? If you notice that x minus 2 is a factor in that one, and it's a factor in that one, isn't it? So they're both common, aren't they? So if I do a GCF, in which I decide which is the greatest common factor, the two yellow things, I divide both by the greatest common factor, just like we did in the first lesson of factoring. The Greatest common factor goes outside, and in here is the answers, yes? Cancel, cancel, x. Cancel, cancel, plus 3. See? That's why it works. Is everybody cool with why it works? Now I'm going to give you a real handy little trick that now that you know why it works, if you aren't lying to me, I'm going to give you a real handy little trick that will make this so easy for you no matter how complicated it gets. You already agree that those two are the same, yes? Watch this. A equals x minus 2. Right? What is that highlighted in yellow? X minus 2. No, guys. It's x minus 2. It says right there, x minus 2. But over here, what did I say x minus 2 was? So what can I rewrite this as? XA plus 3A. Now you quite plainly see that A is a factor in both, yes? So I bring A out and I'm left with x plus 3. But there is no A anywhere because A equals x minus 2. So what would I write there?
X minus 2. Fascinating.
And if you know why it works, then that little A move is very handy. It makes it very easy to do. So here you will notice it's the exact same thing, right? Those are common factors. You could divide them out, but that's cumbersome and ugly. But if you make both of those anything else, A and A, well, I wouldn't use A because we have A's and B's here. Make them Q. So that's 2AQ, BQ. Q comes out. There it is. Right? Now, will that work in number 10? Not really, because of what? Those are not the same, are they? Because according to the first one there, the 2x is positive, yes? But it's negative in the other one. Whew, that's a pain. So watch what happens if I expand this. What do I get? Negative 15 plus 10x. Agreed? Everyone agrees?
I totally agree.
And I would rewrite that, because I'm a math guy and I like it to look pretty, as 10x minus 15. Yeah? Everybody sees that? Look at it really closely. Burn it into your brain like that thing at science where you stare at something for a long time, then you look away, and then you look back and it's still there. Do that right now. It's in your heads?
We're going back. Oh, it's
Okay.
10.
All right. Now, watch this.
Wait, I forgot.
I divide by negative 1. What's 3 divided by negative 1? Negative 3. So the negative 1 goes out front, yes? So I would have negative 1 times negative 3. And what's negative 2x divided by negative 1? Plus 2x, yes? Now, rewrite that the way we would like it, nice and pretty. 2x minus 3, yeah? Multiply that negative 1 back in, and what do I get? Negative 2x plus 3. Hey, wait a minute, it's the same. Right? So if I factor out that negative 1, because negative 1 goes into everything, then what's going to be out front? It's going to be positive 5, and in there is going to be negative 3 plus 2x, yes?
Yeah, which is the same thing.
When I multiply that 5 in there, what do I get? Negative 15 plus 10x, yeah? What was burned into your brain? That. Okay.
Math makes sense.
Negative 1 is so helpful. Like, if you want
Negative 1 is like your best friend.
If you want something positive, just multiply by negative
Yep.
x, solves all your problems.
Okay, that makes up for my knowledge.
So, when I get that negative 1 out of there, I then have x, 2x minus 3, plus 5, 2x minus 3. Now does my little A trick work? Yeah. X plus 5, 2x minus 3. Gouda? Gouda for grapes. And then I asked you to do 1, 2 expansions? Just these 2, yeah? I got you to do this one to remind you of what is this? Is it x cubed plus 27? No. That's what it is when you haven't paid attention in math class, when you've been texting and Snapchatting and talking to your friend about your weekend. That is what you are going to put on your test. But none of you would ever put that on your test because, of course, you know that that is x plus 3 times x plus 3 times x plus 3, which, of course, you know is x plus 3 times x squared plus 6x plus 9. And, of course, you know that is x cubed plus 6x squared plus 9x plus 3x squared plus 18x plus 27, which is x cubed plus 9x squared plus 27x plus 27. Right? Of course you do, because you all can multiply. What about that one? 10x squared
minus 6xy
minus 6xy
plus 20xy minus 12y squared.
Why am I bringing this back to haunt you now?
Because they're getting bigger and stuff, so like it gets more complicated. So if you just skip ahead, then it will mess up.
Partly, but mostly because what is factoring?
If it's negative 6 and positive 20, shouldn't it be positive 20?
Yes, of course it should.
And also, it's minus 6xy plus 20x. So shouldn't there
That's
be
what,
Well,
yeah.
no, just there you go.
What is factoring? It's the reverse of expansion, yes? So I need you guys to see as often as possible that those are factors of that. Yellow, blue, green. Understand? You need to be aware of what makes up the stuff we are factoring. Because if I add letters to the simplest ones, very often I have kids, I don't know what to do there. Because they are not able to make the connection between factors and expanded form, which is why I'm reminding you once again how to expand. Everybody cool? Cool in the gang? All right. All right, all right, all right.
What was his name? Michael McCarthy?
Matthew McConaughey.
Matthew McConaughey.
Oh,
Michael McCarthy, yeah.
Does he have a brother?
He is the bad guy in The Gunslinger. If you,
He doesn't know.
He has no idea.
it just came out. I read all the books.
Is the books better than the movie?
The first book is probably amongst some of the better writing of the latter quarter of the 20th century in popular fiction. It's very, very good. The second one is okay. The third one is pretty good again. The fourth one is crap. The fifth one is I lie. The fourth one is great. The fifth one is meh. The sixth one is spectacular. The seventh one is meh to bleh. The eighth one is bleh. And the ninth one is bleh.
Oh. So it was kind of like good and then it was.
Huh?
You should have just stopped.
These authors are weird, man. Stephen King had this thing in his head, and then he got run over by a car, and then he just had to finish it
He
off.
got run over by a car?
Yeah, he was nearly killed.
When?
I don't know, 15 years ago, 20 years ago. Stephen King,
An author.
the author. He wrote It.
Yeah.
And a great many other books that were turned into movies. Cujo, Thinner, Carrie, what? Under the Dome was the TV show, yeah.
Yeah, should you like Slumdog Millionaire? No,
I didn't watch this. It's awesome. Kind of graphic, but it's good.
Anyways, so I don't even know how that happened. Oh, Matthew McConaughey. Yeah, he's the bad guy.
Does he have a brother? Paul?
No. Paul McCartney is the singer, was one of the singers of the Beatles.
Oh, oh my gosh, that's where I got the McCartney. Oh.
No, he plays bass.
Did you know that Seth MacFarlane is
And he's left-handed. What?
Seth MacFarlane is worth $150 million.
Yes, that is what is wrong with our universe.
What? Seth MacFarlane?
Wait, who's that guy?
Justin Bieber is worth 220 million.
That is what is wrong with our universe.
Bill Gates is worth 76.
There was an article, or there was an episode of back before Bill Cosby was a rapist. There was an episode of Bill Cosby's show in which they went to an alternate future where the famous people were the people that deserved to be famous. ER doctors, cops, teachers. And teachers were being recruited by schools and being offered huge contracts and things and doctors and things like that. Not, yes,
Farley is a guy from Family Guy, right?
yes.
Peter?
He does Peter's voice. He was also in 1 Million Ways to Die in the West. He's also the captain on the TV show The Orville.
He's also like 80% of the characters on The Simpsons.
No, he's not. Seth MacFarlane has nothing to do with The Simpsons.
No, he just-
Harry Shearer has to do with The
Maybe I'm
Simpsons.
thinking of Family Guy then.
Family Guy is what you were thinking of. Huh? They have done a crossover. But the best crossover was when Homer Simpson opened the newspaper and saw Peter Griffin. The headline was plagiarism, which was truly the best because without The Simpsons, Family Guy wouldn't be there. Family Guy is for people that aren't quite intelligent enough to follow The Simpsons. Because when they're in trouble on Family Guy, they resort to things like calling Meg an ugly fatso and things like that. See? It's not actually funny. But when Peter does it, everyone's, ha ha ha, that's hilarious. It's a time-honored tradition in comedy. When you can't be funny, you swear or say dirty things. And then people laugh. Also why Russell Peters is famous. Because he's not actually funny. He just says things that people don't actually say. So everybody thinks he's a genius. It doesn't take rocket science, right? I could make fun of nerdy white math teachers. And everybody, see, you're already laughing. I didn't even actually tell a joke, right? He hasn't stopped laughing, and I haven't told a joke yet. I have not done one punchline. I have just been speaking. And he can't stop. And yet, people pay comics millions of dollars. Seinfeld has sold out the Abbotsford community, or the Abbotsford Sports and Entertainment Complex, in a week. He has sold it out. All Seinfeld has ever done is talk like this about nothing. And people think he's brilliant. Do I think he's brilliant? Yes, I think he's brilliant, but all he is doing is talking. I do that every day of the year, 180 days a year. Ain't nobody paying me no millions of dollars. She not paying me millions of dollars.
But she's paying attention. Or something.
Seinfeld was so damn funny, he walked away from his TV series when they offered him $10 million per episode.
Why did he walk away?
Why does that much money exist?
Because he doesn't need that much money.
But
Nobody needs that much money.
Even $1 million is a lot.
He was, and then he was the star of the show Seinfeld, and now he is back to being a stand-up comic. But again, he changed stand-up comedy from a bunch of guys standing up there telling one-liners, jokes. He was the first guy to do really that observational comedy, where you just look, you look at a situation, you see the funny stuff in it. Huh? Bill Burr is, if I'm not mistaken, I'm not sure about the name, I believe he is the guy that Dennis Leary ripped off all of his comedy from. Isn't Bill Burr old and dead? Oh, then I am not speaking of the same dude. So,
A lot of people are old and dead.
well, billions of people have been dead. That's kind of the point.
But are they old and dead?
At some point, they were old and dead. Well, at some point, they were old. It's difficult to be old and dead. You were either one or the other.
But
Because once you are dead, you are no longer collecting age, so you are no longer getting older or younger. You're just dead.
But they're also, but they could be old and dead, young and dead, depending on what time when they die.
Oh, they are young when they died. That doesn't make them young and dead. They are young or dead.
Then dead.
All right.
Wait, Mr. Myers, really quickly. Just last question. Is it true that when you die, your hair still grows?
No, the rest of your body shrinks. So your hair appears to grow. Same with your fingernails.
Wait, what happened?
Nothing. I was just
When
asking.
you die, your hair.
Your body shrinks so it looks like your hair is
Die,
longer
your
than
hair is
nails.
When you die, your hair.
You grow.
No, when you die, when you're dead.
Oh, when you die.
See, I have to make up words for him to understand. I have to say you're dead.
That makes more sense. Ketchup.
But you're deading.
No ketchup. Just
Where is Lauren though? I don't get it. She was with me during lunch.
Lauren doesn't like this class.
But she likes me.
I am
think.
surprised she is here as often as she is.
That's just her resting face.
wait, where is she?
Yeah.
Oh, she's right there.
She's there every class.
She's right here. She's not, and I'm really lonely. I don't know what I do with her.
That's sort of resting.
Boring.
It's recording.
I know it's recording. Lauren knows that I know that Lauren doesn't like math class. We talk about it all the time. It's not news to any of us.
You see it directly?
I know.
I know. I was agreeing to your statement.
What do you notice
I couldn't talk.
when you have the same thing with plus and minus? When you expand it, they drop out. Yes?
Yes.
Now, you should also notice something about that and that. What do you notice? They are perfect squares. And you should notice that particular operation in the middle, subtraction, which should then lead you to look up at the title of today's lesson. Difference of squares. That is my all-time overall favorite font.
What is it called?
Cocktail Bubbly.
I'm gonna take a note of that.
So, if you have two perfect squares and they are in a different situation, which is subtraction, then you can factor them as such. And you will notice that there is a relation between x, and x squared. And there is a relation between 4, and 16. What are they? The square root of the first term, the square root of the second term, and a plus and a minus in between them, yes? Now we have talked to death about why it works, right? We have expanded it, we have deconstructed it, we have factored it when we left this 0x in the middle of it. So all of you should understand why this works, yes? Which means once you understand why, I am able to show you how, right? What you are actually doing. And what it is simply this. If you have anything squared minus anything squared, the factored version is always the square root of a plus the square root of b multiplied by the square root of a minus the square root of b, no matter what they are. Okay? All right. Now there are some tricky McTrickleton things here, right? And I'm going to address them over in this blank space. What is the square root of x squared? X. So logically, what is the square root of x to the fourth? X squared. What is the square root of x to the sixth? X cubed. Right? What then is the square root of x cubed?
1.5, which is the same as the fraction that we can write.
X 1.5.
It's the same.
Oh no, he's doing doing the thing where he just looks at us and waits till we get the right answer?
It is irrational.
3 years.
It does not have a perfect square.
What make it
What is the square root of x to the 5th?
irrational?
Irrational. So now you should be able to give yourself a little reminder of when you can do a square root and when you can't. What is it? An even numbered exponent. And what do I do to find that square root? 2, 1, 4, 2, 6, 3. You divide by 2. So, you now know everything you need to know to do the first few questions. Look at that first one. Is that a difference of squares? Yes. How do you know that, Leighton? Tell me one thing.
Because x16, the exponent is a even.
That is even, so it is a perfect square. And that is a perfect square because square root of 1 is 1. So what would we write here? x8
Minus
Am I done? Of course not. Why? Because 8 and 1. Are we changing this?
no.
No. x8 plus 1. What does this become?
4. 9.
Plus 1 and...
X4 plus 1. Because I'm on the x.
Now what? Am I done?
No,
Of course not. Why?
keep on going until you can't anymore.
Exactly.
Oh boy. A lot of writing.
Am I done? Of course not.
But doesn't it make more sense just to stop? Because then it looks simpler.
Now, would I ever have written all that out?
No.
Why?
Because you just know sugar.
It's ridiculous.
Because I know that that 16 is going to break down that many times. 8, 4, 2, 1. And then I need one last one with the minus. When you are doing it, could you leave this and just continue to factor this outside one and then bring them all down at the end?
Yeah.
Yes. Why did I write it all down here? Because it's notes to show you to understand it. Now, look at 2. It looks different. Are you allowed to say, I can't do it? No, of course not. Because looks don't matter. If there was no x there, what would it be? Y plus 15, y minus 15, right? If there was no y there, what would it be? X plus 15, x minus 15. But there is an x and a y, so it must be xy plus 15, xy minus 15. Right?
Yeah.
That's just common sense. There is no trickery about it. There is no jiggery-pokery about it. It is simply logic. And nothing makes us math teachers want to stab a ruler into our eye more than having kids not try what they already know. Look at 3. Is it a perfect square? How do you know? 8 is even, and 144 square roots to 12. So what would it be?
Z 4 plus 12. Z 4 take away 12.
Am I done?
Yeah.
No. Yeah.
Yeah.
No. No. It's 12.
12 is in the
Actually, yeah.
12 is a square root. Is 12 a perfect square? No, because every number is a square root.
Yeah. That's what I meant.
Yeah? All right. Look at 4. Tell me what's different.
It has a coefficient.
It's got a coefficient. But if there was no 4 there, could you do it? Excellent. If there was no 25 there, could you do it? Excellent. If there was no y squared, what would you do with 25? Square root it. So that only makes sense. If there was no x, what would you do with 4? Square root it. So do you know how to handle this? What is the answer?
2x cubed plus 5y 2x cubed.
Well, no, not really. You're done you have enough knowledge to solve all of these difference of square questions. Will you be able to? I do not know. Now, that's how easy it is. Hey, whoa, 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 I leave that much blank space for a reason there, sister.
Because you were really big.
Well, that's your problem. You've yet to figure out by page 162 that if I leave that much white space, there isn't more coming? Really? It's on page 162.
But we haven't done all the pages beforehand, have we? Wow. Yeah.
I see.
I thought you used to go in an order of books. Wow. There's not much left.
All right. So now we start to mess with things a little bit. Is this okay?
Boy. So far, so good.
Can I do that?
No.
Wait, yeah.
Of course I can. Because of what?
32 and
So-
7.
Isn't there common
DCF.
factor?
Oh, we did do that on purpose.
Uh-huh.
That's what.
What is the common factor?
2.
2. What do I get?
16
You get 16.
X equals 25.
Now what?
Now you do the difference of squares.
Now you can do it.
What is it?
4x plus 5y.
And then the same thing but negative.
What if I put a Q there? What would you do?
You can take the Q out. but
You would take the Q out.
You should finish the bracket.
What if I put x to the third and x right there? What would be out here? There'd be an x out there. And then everything would be the same. Yeah? That's all the permutations of that move. Do you feel you are comfortable with that move?
Yes.
Excellent. Let's do another move.
Why did you make a count?
What are you going to do there?
Isn't that x minus 5 times x minus 5
Yes, it is.
minus 81?
Yes.
And then the minus 81
Yes.
in
That's one way to do it.
or if it, I don't know.
So what Sam is saying is, all right, that's going to be x squared minus 10x plus 25 minus 81, which would be x squared minus 10x minus 64, right? I lie, not 64. 44, dummy head. No, 25 minus 81 is not 44. 25 minus 81 is
64.
64, I was right. And that, of course, would factor to what?
Oh,
X.
You could take out nothing.
X plus 16,
Oh, right.
x, sorry, minus 16,
X.
x plus 6, right?
Yeah.
You could do that, yeah?
Yeah.
Everyone agrees?
I believe
Everyone agrees with what Sam has done, yeah?
it makes sense.
Wait, what?
16 and 6.
16 times 6 does not equal 16.
Oh, sorry, 16 times.
4.
Sorry, I'm a dummy head. I'm a dummy head. When you got to there, what would you do?
You would do X.
Because that is,
Two numbers that would multiply to 64.
this is, yeah, you guys are clowns. This is
you guys.
81 minus 25 is 56.
I was looking at it, I was like, it's not.
I would just go with the flow.
Anyway, what would you do there? X plus 4, x minus 14. Right?
Yeah.
Everybody sees what Sam has done, yeah?
What you did there.
Now, that was doable, right? No problem, until you look at it this way.
Oh no. Oh no. What's going to happen? I'm scared.
What's that? would I do with that? A plus 9, A minus 9. What's A? X minus 5. X minus 5 plus 9 is X plus 4. X minus 5 minus 9, X minus 14. Hey!
Oh, there, mind blown. That's an backwards way.
You know.
Oh my goodness.
We made that. See, I just did that whole thing
Oh
right there.
my word.
Remember? I just spent a whole time doing that. I made that up. Because when I change that, it becomes much simpler. So what did I do here?
You did it again.
I changed that to something much simpler. Okay? Yeah?
Yes.
So now, put it together in the hardest difference of squares question I can give you.
Oh my goodness.
I lied. There's two that are equally difficult. We'll do the first one first. Just give me a moment. I need to work this out in my brain. 20 Can you figure out 7?
Oh yes, I can. So believe in myself.
No, I'm throwing down a fat beat.
Yes, you can.
Okay, you can do it.
I do it. Okay, so what you do with the other one?
120.
Can you do x minus 3 times x minus 3, right?
You could expand it all out, factor it all. That'd be crazy talk.
But we should do it.
Okay, you're gonna have some crazy shortcut at the end when we do some crazy long thing.
Yeah, the crazy shortcut at the end is right there. What's that?
I know.
Same thing.
Oh wait.
That's literally what I'm doing. Oh my gosh, you guys.
We never said you weren't. We didn't tell you not to do it.
Who's not square root of 20?
Now what?
Cry about it.
No, you don't cry about it. You do what I tell you to do.
Five.
Take
Try.
5 out.
Oh,
Five. Take 5.
Simplify. Oh my gosh.
Now what?
Oh my gosh, my.
Is that it? What's
Now you can
5A minus
do
2a
5.
plus 3y
What's 2 times
2a minus 3y. But what's a?
2? A is
X minus 3. So it's 5. 2 times x minus 3 is 2x minus 6 plus 3y, right?
Yeah.
2x minus 6
Minus.
minus 3y.
Oh my
Wait,
god.
wait, wait. Hold up. This
Wait, it's negative 6 because it's 2a. Right?
Yes,
Yeah.
there's a 2 out front.
Yeah, okay.
Okay?
I'm with you.
he was in San
Now, the actual, what I find to be the most difficult of these. Well, then just watch.
You can do the double shortcut.
Do it.
Double
Don't
shortcut.
cry.
Okay,
Simplify.
change x minus 3 to 8. And then
Try.
x plus 4. Is that 4 or 9?
Take it out.
And the C and the D and the H.
See how much nicer that looks to work with.
Now what?
Oh, can we take 2 out?
You.
Listen to that guy. Now what?
You take 2 out.
I would have taken 4 out up here.
Yeah,
But
Yeah, but like, we didn't, so.
all right, we'll take 4 out up here.
You always tell us to simplify what we can.
Yes, I know, but nobody did.
A plus 2b. And then a
See, this is where I'm going with this actually. as I started writing this, nobody stopped me.
I stopped you after.
Why did I start writing? Because I saw square minus square.
I said don't cry, simplify.
You said, true. I should take a 4 out, shouldn't I?
That's a good motto to live by.
And now what?
I simplify.
Don't cry, craft.
It goes past math class.
Now what?
Now you swear that.
Lauren, we were just talking about you.
Where did you go?
All the things, all the things.
What's A? Minus 2x plus 8, right? X minus 3 plus 2x plus 8, right? What? Oh my good gravy.
Oh, that's a big one.
I'm not going to say a word for a second. I'm going to let you think about this.
Thinking about it.
Where does the A come from?
The A is
The A is a variable, right?
A is equal
Now,
to x.
once again, I'm going to show you again, and maybe you will pay attention instead of talking to your neighbor or doing whatever it is that you were doing that made you miss it the first 4 times. This is ugly. It is difficult to work with. So I am going to substitute that with the letter A and that with the letter B. This factor is squared, which means that A is squared, which means I can rewrite it as 4A squared minus 16B squared, and that is easier to deal with. Now, I will factor out the 4. A squared minus 4B squared. I will then factor that difference of squares. A plus 2B, A minus 2B. Now I have factored it as far as I can. As you have rightly noticed, there is no A in the original equation. I made this A. So what must I make this now? 4, it is no longer A, it is x minus 3, plus, it is not 2b, it is 2 times x plus 4, which is 2x plus 8. Yes? And then, it is not A, it is x minus 3, minus 2x plus 8. Now, what do I do with my x's? I collect like terms, just like I did in the 9th grade. I have one x there, and I'm adding 2 x's. 3 x's. I have negative 3, and I am adding 8.
Plus 5.
I have one x there, and I am subtracting 2 x's. Minus x. I have negative 3, and I am subtracting 8. 11. And now I am done. Hardest question I can give you.
What about the negative for the x?
Now stop for a moment. Well, it wouldn't matter. It's still going to be a negative before there. This is being recorded, so I have no fear. Now, if you do not do this, then you have to remember that the square root of x minus 3 is x minus 3. That's fine. You're welcome to do that. However, if you don't remember that and you do Sam's version of things, and I'm not putting it down because it will still work, please observe how cumbersome that gets. So we are going to use Sam's version, which was expand everything. That gives us 4x squared minus 6x plus 9 minus 16x squared plus 8x plus 16. Then you multiply that out, 4x squared minus 24x plus 36 minus 16x squared minus 128x minus 256. Then you collect your like terms to get negative 12x squared minus 148, 152x minus 220. And you would have to factor that. Or you do this. Does this work? Yes. I haven't yet taught you how to factor anything with that at the front. That's the fourth thing we're going to learn. But doing this substitution move, you can do it all in your head in 2 seconds. Do I care which method you use? No. But I will warn you. Understanding how this works is going to be a very, very, very good tool for you in higher level math. Okay? Everybody cool? Sweet. Your job now is page 165. Go diddly o. Oh, it's not 165. I have changed the order around here. You guys, your next page, I do not want it to be 163. I want you to flip to and do 165. That's, yeah, what I actually said. Not what is in your book. You're going to skip 163, 164. We are going to come back to them later. I don't know how they got that out of order.
So just do assignment number 4, it says.
Yes.
All right.
Page 165. That is your job right now. Now, Lauren, you were not here for difference of squares. So I will take 1 second and show you what you need to know. You saw the crazy stuff at the end. So you shouldn't have too much trouble. So you guys are working on this. I am number 1. Taylor.
Yes.
Go.
Okay, x plus 7, x minus 7.
Absolutely right.
Thank you.
Number 2, Byron.
3x plus 5y times 3x plus 5y.
Does order matter?
Not really.
No, not at all. Number 3, Michael Parhar.
2x plus 5.
Nicely done. 4, who do I want to bug? I'm going to pick someone at random. I'm not even going to look at who's not paying attention. Parlene. Was she really not paying attention?
No.
Parlene's in this class.
I literally did not know.
Is she done? No. No, why?
And go straight up back because
X
it's
plus 1, x minus 1.
Absolutely right. Oh, Mr. Myers throwing it back into the middle right here with one of those old ones.
I can do
Why
that.
you got to be that way, Sarah?
Oh yeah, it's x, take away 5 and then x, take away 12.
You could say minus. We are in high school.
Take away. No, her mom's an elementary school teacher. That's
6.
yeah.
Let's go with Lindsay. And 7. Let's go with Gurpinder.
3 bracket x minus 4. And then bracket x plus 4.
Lovely. Well done. 8. Let's go with Armand.
Wait, and then in brackets 8 minus 4, and then 8 plus 4.
Whoop, whoop. 9. Let's go with Avipal.
8 bracket 8 plus 3 bracket.
Whoo, somebody stop him. 10. Amshuman.
Oh boy. That's 1/3. No. Yeah, 1/3 minus x and 1/3 plus
Sweet. 11. Sam.
X minus 1 and X plus 5.
Sweet. 13 or 12. What?
It's x plus 1 and then x minus 1.
What did I do?
X plus 5 minus
Oh, I did it backwards, yeah. Okay. 12. Sukmin.
X plus 3 and x plus 5.
X plus.
X plus 3, sorry.
Is that as simple as we can write it?
Yes. Oh, x plus 3 squared.
Lovely. And 13. Who do I want? Alicia.
X to the 4th plus 4, x squared plus 2, x plus 1, x Woo!
Booyah, Grandma.
X plus 2 minus X plus
What?
Sorry, that would be all.
wait, X what she is.
What's the problem?
Mine is
That would be x to the 4th plus 4, x to the 4th minus 4. Then you would break that down. X squared plus 2. Oh, yeah, x squared plus 2 minus 2. That's where we got to stop. Alicia. Come on, man. Does 2 have a square root? Come on.
Oh,
You were cruising along so well, I just was following and writing. Blip, 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 blip. But that's okay. You're not the first person to tell me that 1, 1, and the hypotenuse of that is 2. You're not the first person to say that. And you won't be the last, I know.
Wait, the hypotenuse would still be 1.
No,
No, wait.
it's the square root of 2.
Okay,
Aight.
never mind.
square root.
Okay, now we are approaching close enough to the end of the day. Page 163 and 164 are HW. And you have a quiz on GCF.
It's a quiz, y'all. In trigonometry. No, I was gonna say. He started writing dry. I was like, wow, that's a throwback.
Yes.
Wednesday.
That could be anyone.
Wait, that could be any November 22nd.
That could be
Wait,
so it's-
that could be BC or AD. Oh, wait, we don't use AD because that's culturally insensitive. So it's CE. No, it's Anno Domini.
Oh, I thought it was that one.
No,
That works too.
Current era.
Common Era.
Common era.
So, Tamar, why is it called trinomial 1?
Because there's another kind of trinomial factoring that I've yet to teach you.
Oh,
Huh?
very nice. We did that.
The one that is the Common Era. Ours.
Well, it's pretty common for us, but in the future, when they have a new one,
We have yet to change over to Stardate like in Star Trek. Don't worry about it.
but then it won't be the common era anymore.
Yes, it was. The whole point of Star Trek was the world had straightened itself out.
What's the point? The point is, so we call it common era because it's common to us. But in the future, they change it and they call it common era. This period of time, common era, it will be confusing. So it's a very stupid option.
Whatever.